with chapter 6, we've been doing in class a lot of bell ringers, and in the bell ringers we've been solving the systems. In this class, this next chapter is kind of similar in one way to what we just got done doing, but in another way it's completely different. The way it's similar is basically over the next few lessons, I'm going to show you multiple ways of solving the same type of problem. So, again, why learn multiple ways to do something? Yeah, this is a chapter that you really want to know multiple ways, because different problems definitely lead to this method is better than this method for this problem. Yes, are you going to end up with kind of your favorite method? Everybody does. But more than anything else, you are going to want to know multiple ways, because it's going to, you might look at one problem and go, ooh, I'm going to choose this method because it'd be easy to use this method. Where a different method, it might be a little bit harder, okay? Everybody take a look at page 383, okay? So here's basically what we're doing. You're going to be given, let's say, 2x plus 5y is equal to 8. And you're going to be given 3x minus 2y equals 5. Okay? Now, this is what is known as a system of equations. Okay? System of equations are a really, really useful type of problem, because there's so many different applications to systems of equations. For example, in a real life scenario, if you're selling anything, let's say you're selling candy bars, okay? What's the first thing you have to decide as a person that's making a candy bar and you're going to sell it? What's the first thing you got to decide? Okay, guys, this is where you guys got to talk. This will go a lot better if you guys are talking. If I'm opening a candy store and I make really, really good fudge, what's the first decision I have to make? How much am I going to sell it for? Right? Now, there's two problems here, though. The problem first is the higher I set the price, so price. The higher I set the price, what's going to happen? Fewer sales, right? So the higher I set the price, nobody's going to buy it, right? But if I set the price really low, a lot of people would buy it, right? Okay. But where do I set it then? Just somewhere in the middle? Well, now there's going to be another scenario going on at the exact same time. I also have to make these things, right? Now, so I figure out this equation first. I do some surveys, and I ask, hey, here's a free candy bar. How much would you pay for this? Like, what would be a reasonable price for you? If I sold it at, 10 cents, would you buy it? Oh, absolutely. I'd buy a whole bunch. I'd buy one every day. If I sold it for $10, would you buy it? Oh, no way. That's not that good, And I do some surveys, and I figure out that equation, right? And then there's another equation at the same time. I have to make this fudge, right? In order to make the fudge, what do I have to do as a business person? I have to buy all the flour and all the chocolate and all the whatever ingredients, right? And then I got to also pay somebody to make the stuff. I got to figure out my costs. And the fewer I make, like as a salesman, if I go to the store and I buy one thing of flour, the price is kind of high, right? But if I go to the store and say, I want to buy 1,000 things of flour, what do? I get to buy it for cheaper, don't I? So there's this other equation that ends up happening with, if I don't make very much, right? My price of everything, my costs, right, are really high. So I'm not going to make much money. Okay? And then if I sell or make more, right, it's going to cost me more, but at the same time I might get a better price. So I have this other equation going this way. So where do I, as a business person, set my price? How do I know what the best price for me to use is? The answer is right there, because that's going to maximize my profits. If I set it too low, yeah, I'm going to sell a lot, but I'm not going to make a lot of money because I'm not bringing in that much money. If I sell it too high, I'm not going to sell enough, right? So I got to find somewhere along this line to set that price. But I also have these costs of expenses, right, that I have to operate with. So the place to set the price is right there at that intersection. That's an example of one use of these. Okay? What we're going to be dealing with are what are called linear systems. You have two different equations, you have two different lines going on at the same time. Okay? The question becomes, what's the answer? Okay? Well, one method of solving these, is to graph them. Okay? And that's exactly what, we would do. So if I saw a problem like this, 2x plus 5y equals 8, 2x plus 5y equals 8, and 3x minus 2y equals 5, if I want to solve this system and basically figure out where these intersect, one method is to graph them. Now, what is the problem with the graphing method for this problem right here? Is it easy to graph this right now? No. I have a couple different methods. I could solve it for y, so I can get my slope and y-intercept. I could find my x and y-intercept really easily. I could just say, how do you find my x-intercept? Well, you plug in a 0 for y, so that becomes 0, so I get 2x equals 8, so x equals 4. So I have on the x-axis 1, 2, 3, 4. And then over here I go y-intercept. How do you find the y-intercept? Well, plug in a 0 for x, so you get 5y equals 8. I have kind of an ugly point here, right? So 8/5, that's like 1.6, somewhere in there. This equation is going to look something like that. And I can do the same thing for this. How do you find the x-intercept? Well, the x-intercept, the y becomes 0, so you get 3x equals 5. So x equals 5/3, which is like 1.6 repeating. So it's like somewhere in there. And then my y-intercept, I can do the same thing. Find the x is 0, so you get negative 2 y equals 5, so y equals negative 5/2, which is like negative 2.5. So over here somewhere, and I can draw that line. Where do you think the answer is going to be? Where's the answer to this problem? Where they cross. Now, with this problem, am I very confident that I know the answer? Why not? I got ugly decimals. It's kind of hard to be precise. So now this problem, the book, what it wants us to do here is not necessarily do this, but just to test, is this the answer? They're saying, is this the correct answer to this problem? There is a really, really easy way to check. Plug it in. Take that 2x plus 5y equals 8. Plug that point in. Instead of an x, we're going to plug in a negative 1. Instead of a y, we're going to plug in a 2. Does this work? What's 2 times negative 1? Negative 2 plus 5 times 2 is 10. Does that equal 8? Yeah, it worked in that equation. Does that mean it's the correct answer? No. All it means is this point of negative 1, 2. That means that blue line goes through that point. Okay, we established it works in one of the two lines. But for this to satisfy this system, it has to work in both of them. So we have to also check the 3x minus 2y equals 5. Well, 3 times the negative 1 minus 2 times the 2, and let's see if it equals 5. 3 times negative 1 is negative 3. That'd be negative 4. Does that equal 5? Does negative 3 minus 4 equal 5? No, it equals negative 7. This is not the answer to this system of equations. Checking your answers is actually a really, really easy thing to do. Okay, because all you have to do is plug in the x and the y and see if it works. This is a test that at the end of the test, there is no way you should get a single problem wrong. Because after I show you how to solve them, how do you check your answers? You just plug it in, see if it works. If it works in both, you know without a shadow of a doubt you have the right answers. If you plug it in and it doesn't work in both of them, you know what's wrong. So if you look at like let's take this one. Let's say I give you this system. We got 2x plus y equals 5. We've got negative 2x plus y equals 1. Here's our system of equations. And they want us to test, is this the solution to that problem? Well, all you have to do is say 2x plus y equals 5. Instead of the x, what are we going to plug in? Plug in a 1. Instead of a y, we're going to plug in the 3 and see if it works. Abby, please pay attention. 2 times 1 is 2 plus 3. Yes, 2 plus 3 is 5, right? It works in that equation. Check the second one. Negative 2x plus y equals 1. Negative 2 times the 1. The y becomes a 3. Negative 2 times 1 is negative 2. What's negative 2 plus 3? 1 equals 1. Is that the correct answer to this problem? Yes. Now, you're not going to be always given this answer. Let's say this was a problem that we had to do from the start, where it's 2x plus y equals 5. And what was the other one? Negative 2x plus y equals 1. Let's say this was a problem that we did not have the solution to. And we had to solve this from the start. One method, and this is the first method we're going to use, is solve by graphing. What's the easiest type of equation to graph? If it's in slope-intercept form, right? So the first thing I would say is, can we put these both equal solve for y really easily? Yeah, what would this one be, solve for y? The only thing I have to do is move the 2x over, right? Which would make it negative 2x plus 5. Where do I start that line? Up 5. So I go 1, 2, 3, 4, 5. From there, where do I go? Down 2 over 1. Down 2 over 1. Down 2 over 1. And I draw the line. Okay? And yeah, extend it a little bit in both directions. What's the next thing I need to do? Do the other one, right? So, what's this one going to equal? This one I move the 2x to the other side. Now it becomes positive 2x plus 1. Where do I start that line? Up 1. And from there I go up 2 over 1. Up 2 over 1. Up 2 over 1. And then I draw that line. Where's the answer to this question? Where's the answer to all the questions that we're going to do in this whole chapter? Right at where they cross. We're looking for where the two lines cross. That's all you're looking for. So the answer is 1, 1, 2, 3. 1, 3. Every single new method we solve that I teach you, we're going to have a pros and cons method. We're going to have a pros and cons discussion. Graphing method. What are some pros? What are some cons? Huh? Well, the answer to every single problem that we do this whole chapter is going to be a point. We're looking for where do the two lines cross. I'd say it's easy to see the answer, isn't it? Like once you have it graphed, isn't that really easy to see? Like, yep, there's my answer. Okay, that's a good pro. What's some cons? It's time consuming. Graphing method absolutely is a time consuming method. Absolutely. No question about it. It takes time to graph lines. When would be the only time it is like a good, quick method? What would be the type of problem that you'd go, ooh, let's do graphing method here? What could make your life easy? Or even if they're not whole numbers, what if the problem was y equals 2/3 x minus 1 and y equals negative 4/5 x plus 3? Why do you think I personally would go, ooh, graphing method, graphing method? What? It's already in slope-intercept form. This is easy. Where do I start the first equation? Negative 1. And then I count? Up 2 over 3. Up 2 over 3. Up 2 over 3. I draw that line, right? I mean, I would use a ruler, be precise kind of thing. What about this one? I start 1, 2, 3, and then I count 1, 2, 3, 4, 1, 2, 3, 4, 5. 1, 2, 3, 4, 1, 2, 3, 4, 5. Where do I find the answer? Where they cross. I think the answer looks pretty much like 3, 1, right? Am I really confident the answer is 3, 1? Why? Why? Why am I not 100% confident that the answer is 3, 1? One of the biggest problems with the graphing method is it really is hard to be precise. If the answer to this problem is a decimal, is it easy to see in the graphing method? No. For this problem here, I mean, I know it goes through some certain points. Like I know this one started at up 3 and went down 4 over 1, 2, 3, 4, 5. Down 1, 2, 3, 4 over 1, 2, 3, 4, 5. I know that line looks something really close to that, right? Now, even that is a little bit off, but it's pretty darn close, right? And then this line here, I know it went through down 1, and it went up 1, 2 over 1, 2, 3. Up 1, 2 over 1, 2, 3. I know it basically looks like that. Now, when I actually used the straight line tool there, are you confident that the answer is actually 3, 1? Or is it close to that? It's close to that. That's not actually at that point, right? The answer to this question is probably, I don't know, maybe 2.6, 2.7, somewhere in there. So if the answer isn't a nice, pretty answer, the graphing method is a terrible method. It's hard to be precise. It can be very time-consuming. But when would be a good time to do this? Like, what are you kind of hoping for all your problems and your homework going to be today? What do they start in? Aren't we hoping they all start in slope-intercept form? Or at a minimum, close to or easy to. Like the last one I did, was it really hard to move these into slope-intercept form? No, those were pretty easy. So at the worst, we're looking for something like that, okay? Don't worry as far as these types of problems. Am I going to give you 50 problems of homework to do? No, because I know. What's the worst part about the graphing method? It's time-consuming. It really is. Everybody look at page 386. 386. Abby, 386, please. Thank you. Number 2, you don't have to graph it. What is the only thing you have to do in number 2? Plug the point in. See if it works. You have 3x. Oops, wrong button. The first equation is 3x plus y equals 4. The second equation is x minus 3y equals negative 4, right? And they tell us the point 2, negative 2, is the answer. So this is number 2 on page 386. The only thing you have to do is plug the point into each equation and see if it works. So here, you got 3 times, but instead of the x, it becomes a 2. Instead of the y, it becomes a negative 2. Just be careful of your pluses and minuses. What's 3 times 2? 6. That's minus 2. Does that equal 4? Yes. Right? 4 equals 4. That works. Try this one. You plug in, instead of the x, it becomes a 2 minus 3 times negative 2. Does that equal negative 4? Well, you got 2. Negative times a negative becomes a positive 6. Does that equal negative 4? No. Is this the solution to that system of equations then? No. The answer to number 2 is no. Please make sure you're showing your work on those. Do you think on anyone I want to see like the answers to 2, 3, and 4? The only thing you write in your paper is yes or no. No. Make sure you show how you got that. Then you get to number 5. They don't give you the answer. You got to find the answer. What's the benefit of number 5 though? What's the nice part about number 5? The first equation is y equals 1/2 x. The second equation is y equals negative x plus 3. Aren't they already in slope-intercept form? Where's the first equation start? Where's my line start? What's my b value? 0. And from there I count up 1 over 2. Up 1 over 2. Up 1 over 2. I cannot stress enough to you, when you do these, use a ruler. It will help you. Okay? Easy enough? We're going to do some homework in class tomorrow.